Okay, so orbital shapes. An s orbital is spherical, and its size is where the sphere that encloses 90% probability. P orbitals are lobes, and there's 3 of them, one each on the x, y, or z axis. And that is a node where the lobes come together, where there's 0 probability of finding an electron. Kind of makes sense. That's where the nucleus would be. The D and the P are, that's a big old typo there. That's not P, that's F. The D and the F are way more complicated. Now in hydrogen, all orbitals with the same N have the same energy. They're degenerate. With all other elements, the different sublevels have different energy, which I'll show you in a minute. Now, Pauli exclusion principle. No 2 electrons in the same atom can have all 4 quantum numbers the same. And we know that that last one, the m sub s, can be positive 1/2 or negative 1/2. So we can hold 2 electrons. We have opposite spin, and we use an up arrow and a down arrow to show that. So we can use electron configurations, which shows the location of every electron in an atom. It's going to show the principal quantum number, 1, the sublevel, the s, and then the number of electrons is that 2. So the number of electrons is done as a superscript. Okay? Periodic table, it's all this organized for you. So we follow the off-bow principle, which means start at the lowest energy. Okay? You move up. Only when one energy level is full. We also have Hund's rule. Single electrons with the same spin must occupy each equal energy orbital. 4 additional electrons with opposite spins can occupy the same orbital. Okay? So let's look at an orbital diagram, and those will make sense. So here is a full list of energy levels. We've got the lowest energy down here. We've got the highest energy up here. We're not going to need all of this. But remember how we said that they were not degenerate. So look at this. In energy level 2, S has lower energy than P. Energy level 3, S has the lowest energy, then P, then D has the highest. 4 actually has energy that's lower than 3D. So let's do oxygen. Okay, we are going to place all 8 electrons. And we are going to use the Aufbau principle. Start at the lowest energy level. We're going to use the Pauli exclusion principle. Maximum of 2 electrons. They have to have opposite spins. Okay? So we filled energy level 1, so we go up to energy level 2. We've still only used 4 electrons. So now we're going to use Hund's rule. 1, 2, 3. Electrons with the same spin in each of the equal orbitals before we pair up. And now we've used all of the 8 electrons for oxygen. So this is the orbital diagram for it. And instead of this for the 2p, you can see this. And they're both okay ways to do it. So we would write this as the electron configuration 1s, 1s2, 2s2, 2p4.